Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this chemistry series, recently we have completed theory part of periodic table. Now we are going to practice the MCQs on periodic table or classification of elements. Okay. Students, if you still not subscribed on this channel, please click on subscribe button and also click on notification bell. Coming to the first question, guys. The elements belonging to the same group of periodic table have same dash. The elements belonging to the same group of periodic table have the same dash. Same group of periodic table having same valency electrons, correct? They have same valency electrons. Valence electrons are nothing but the electrons which are present in the outermost shell or outermost orbit. So the same group having same number of electrons in the outermost orbit. Those electrons are called as valency electrons. Okay, for example, if you can consider the carbon atomic number 6, mass number is 12. So electronic configuration 1s2, 2s2, 2p4, sorry, 2p2. Okay, so in the second orbit, this is called as outermost orbit. Here how many valence electrons are there? Second orbit 2, and in the second orbit 2 plus 2, so total 4 are considered as valence electrons. Valency electrons. If you can consider nitrogen 7, 14, 1s2, 2s2, 2p3. So in the second orbit, how many we have? 2 plus 3. So total 5 we have. So like that. Okay, like that. So the electrons which are present in the outermost orbit are valency electrons. So answer is option B. Coming to the next question. The scientists classified the elements into metals and non-metals. In the theory, we have discussed in detail about this. Just metals and non-metals, love is there na? Love is there. There is a love between metals and non-metals. Love, as the name love is there. Okay. So the octave theory was proposed by which land? Newland's octave theory. So Lavoisier, there is a love between two, that is metals and non-metals. After that, second, Daberneer trades. Daberneer, three elements grouped together and named as trides. After that, a new land. In the new land, there is a 8 elements grouped together. So you can say octave theory. So the answer is option A. Okay, coming to the next question, guys. According to Newland's octave theory, how many elements exist in the nature? At the time of Newland's octave theory, how many elements exist in the nature? I have given this point in the theory also, that is 56. Only 56 elements are exist together. Okay, exist in the nature. Coming to the next question. Father of periodic table. Who is the father of periodic table? Mendeleev. Mendeleev is considered as father of periodic table. Horizontal lines in the periodic table are called as dash. There is a confusion na? I have given the trick in the theory class also. Horizontal. Just make a trick, that is nothing but HP laptop or HP petrol. Horizontal is periods. Horizontal is periods. Okay. So if the horizontal is period, vertical groups remaining. Okay, coming to the next question. Vertical lines in the periodic table are called as groups. According to Mendeleev's, number of periods and number of groups. So how many students will give wrong answer for this question? Just feel one answer in your mind and check with my answer. Okay. So according to Mendeleev, how many? How many? Just 7 and 9 only, guys. Okay, according to Mendeleev, at the time only 63 elements are exist. Those grouped together as 7 periods and 9 groups only. If they are asking according to modern periodic table, then periods are 7, groups are 18, 7 and 18. Okay, so be careful guys, according to Mendeleev and according to modern periodic table. Okay, and modern periodic table based on atomic number. Atomic number. Okay, and this one Mendeleev atomic mass. Okay, second period in the number of in the second period the number of elements are dash. In the second period how many elements are there? So in the first period we have only two elements. In the second period we have 8 elements each. Third period also we have 8 elements. Fourth period we have 18. Fifth period also we have the 18. Sixth period we have 32. And seventh period we can say that is the incomplete period. Okay. If any new elements added, those will be added in this. So that's why they consider as incomplete. So first period or second period they are asking na 8 elements. Okay, sometimes they will give the question in which of the periods having same elements, that is second and third. In the same way, fourth and fifth also having same number of elements, 18, 18. Okay, so let us take this is the periodic table. Just wait. Where is my cursor? If I want cursor, I want to change the color. Okay. Yes, now it is visible. Okay. So first period, how many we have? Hydrogen, helium, 2. So second, 1, 2, 3, 4, 5, 6, 7, 8. Correct. Third also 8. Fourth, 18. 18. Here 32. Here 32. Here 57 to 71. 57 to 71 is called as lanthanides. So lanthanides belongs to which period? First period, second, third, fourth, fifth, sixth. So sixth lanthanides. Sixth period we have the lanthanide series. In the seventh period we have actinide series. Actinide series 89 to 103. That is also very important guys. Lanthanide series from dash to dash 57 to 71. 57 to 71. Actinide series from 89 to 103. Okay, so all of you getting? So here second period we have 8 elements only. In the modern periodic table, which of the two periods contains 8 elements each? 8 elements each. Just now we have discussed na second and third. Second and third. Okay. In which of the following incomplete period? Last period is said to be incomplete na seventh period. What is the common characteristic of the elements of the same group? Already we have discussed this one. Same group, same valency number of valence electrons. Electrons which are present in the outermost orbit. Periods dash and dash contains lanthanides and actinides. Last two, that is last two means 6 and 7. So answer is option B. An element of atomic number 16 will belongs to dash period. So let us take the first period we have 2 elements, correct? Second period we have 8 elements. Third period we have 8 elements again. So atomic number 16. So up to 2, up to atomic number 2, it is in the first period, correct? That means 1 and 2 in the first period. After that 3, from 3 to 2 plus 8, 10. So that means 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 11, sorry, 12. That means 3 to 3 and 8, sorry, 3 to 8, it is in the second period, correct? 3 to 8, second, 3 to 10, that means total 10, correct? Getting my point or not? I'm confusing, you are confusing. No, I'm not at all confusing, guys. Okay, so very simple math. First period 2 elements, second period 8 elements. Okay, so in the second period they maybe starts from 3 to 10, right? So here the second period, just wait. The second period 3 to 10. Okay, third period 11 to 18. So where is the 16? Here is the 16. So it is belongs to which group? Which period? Third period. Okay. No need to remember that one. Okay, a simple math only. So third period also 8. So up to 10 we have second period only. From 11 to 18, third period. So they are asking 16. So 16 will be lying in this. So that is third period. So answer is third. Okay, very easy. For example, if they have given atomic number 20, 20 is in which period? Okay, so 8 plus 2, 10, 10 plus 2, 18. So up to 18, we have the third period. So more than 18 means it is in the fourth period only. So it is the fourth period. So like that you will get the answer. For example, if they have given atomic number is 9, that is in which period? That is in which period? So up to 2, first period. Up to 10, so from 3 to 10, second period. So it is belongs to second period. So like that you can give the answer. Metals are placed on which side of modern periodic table? Metals are placed on left side, guys. Generally placed on left side. Let us take atomic uh, periodic table here. Metals: lithium, sodium, potassium, rubidium, cesium, francium. All these are considered as alkali metals. These are alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium, radium. So these are left side, correct? So non-metals are right side. So note down that very important points. Here very important point, guys. Metals are left side. And metals are which nature? Basic nature. Basic nature. Non-metals. Non-metals are acidic in nature. Acidic nature. So these are right side. Right side. Okay. Metals are generally, let us take calcium plus 2, sodium plus 1, magnesium plus 2. That means plus. Plus means they are ready to donate. They donate electrons. So that means donate electrons and becomes positive. So those are positive nature. Electropositive nature. Metals are electropositive nature. Non-metals, those are acceptors. Acceptors. Okay, for example, F minus, Cl minus. Okay, so that is minus in the sense electronegative nature. Electronegative nature. Okay, so metals are in the left side, non-metals are right side. In the following, which is lightest metal? lightest metal, that is lithium. Lithium is considered as lightest metal. Okay, very less weight. That's why lithium is used in batteries, portable batteries, in mobile batteries, laptop batteries. We are using lithium ion batteries. Okay, so lithium is the lightest metal. The following, which is liquid metal? Liquid metal, that is mercury. Mercury at room temperature, it is in the form of liquid, correct? Coming to the next one, in the following, which is best conductor of electricity in non-metals case? Be careful, guys. If they are asking, if they have not mentioned anything, then go for silver. If they mentioned metal, then also go for silver. It is not mentioned metal or non-metal. Okay, then answer is silver. That means in all those, if you can consider all those, silver is the best conductor of electricity. Silver is okay. If they mention metals, in the metals also we have silver only. If they mention only in non-metals, silver is a silver is a metal, so we may not consider. In the non-metals, graphite. Graphite is having one free electron. Because of that free electron, it allows the electricity. Okay, so in non-metal case, go with graphite. Silver is a metal, so don't go that one. Okay, be careful. If they are asking the metal, then answer is silver. Answer is silver. Okay, coming to the next one. In the following, which element is highest ionization potential? What is the ionization potential? It is the potential or energy required. Is the energy required to remove one electron from outermost orbit. Okay, if any element participate in the reaction, okay, if any element participate in the reaction, then we can remove that electron, correct? If the element is not at all participate in the reaction, in the chemical reaction, how we can remove the electron? That is not at all possible, correct? Very difficult, correct? For example, if a girl is there, just example I am giving, guys. If a girl is there, or boy, whatever it may be, okay, girl or boy, this girl is not at all interested to make the friendship with anyone. Okay, she not interested to make friendship with anyone. Okay, then if you want take one chocolate from that girl is very difficult, correct or not? So you require a lot of effort to take one chocolate from that girl. Why? Because this girl even may not talk with others. This girl may not talk with others. So then it is very difficult to take one chocolate from her. Correct. So here also, if you what is the ionization potential? It is the energy required to remove one electron from the outermost orbit. If any element having highly reactive, then we can easily take one electron from that one, correct? If that element may not participate in the reaction, it is very difficult, correct? So what are the elements we have that may not participate in the reactions? Noble gases, correct? The noble gases may not participate in the reaction, correct or not? Helium, neon, argon, xenon, krypton, radon, these are noble gases. Those are not at all participate in the reaction. So it is very difficult to remove the electron from that outermost orbit. So we have to put more and more energy. Okay, so here answer is helium. Getting my point? For example, if you can consider cesium, highly reactive, highly reactive. So we can easily remove an electron. For example, if you consider any one boy, here he is highly reactive person, highly friendly nature. Okay, he is ready to talk with any person, if you know or don't know. Okay, so very talkative nature, very friendly, very reactive. So in that case, if you want one chocolate from him, if he has so many chocolates, if you want to take one chocolate from him, is very easy. If we ask also, he will give. Correct. So this person having least ionization potential. Okay. So here finally what I want to say, the element which is non-reactive or which is not participate in chemical action or chemical reaction, that may be having highest IV. Very difficult to remove the electron. Okay, in the same way, which is any reactive, in that case the IP is low ionization potential. Okay, so highest ionization potential, generally noble gases having helium. Here no need to byhead anything. Okay, to avoid byheading, that's why only I am giving this much of concept and all those. Okay, so if you know this one, no need to byhead. Okay, if there is no need to byhead, before the exam also no need to revise all these things. Okay, you can remember this one in your lifetime. Ionization potential. What is the ionization potential? Energy required to remove an electron from the outermost orbit. It is very difficult to remove the electrons if that element is not at all participate in the reaction. So which are not participate in the reaction? Noble gases. Helium is there. Go with the helium. Okay. Which element has least ionization potential? Same question. Least. Here they are asking least. Least means highly reactive. Which is a highly reactive here? Cesium is a highly reactive. So answer is cesium. Okay, answer is cesium. The next one, which has greatest electron affinity or highest electron affinity? Electron affinity is like some opposite type of ionization potential. It is energy released if we add one electron to outermost orbit. Reverse guys, somewhat of reverse, not fully reverse, somewhat of reverse. In IP, ionization potential, we are removing electron. Energy required, here energy requirement here, but energy released here. Okay, for example, if a stable atom is there, any one atom is there, if you add one electron to this atom, there may be some energy released. That energy is nothing but electron affinity. Okay, some energy release, so that concept is called as electron affinity. That means if any atom or element attract more electrons, if any element or atom attract more electrons, if we attract more electrons, then more energy will be released. Correct? More energy will be released. Which are attracting electrons? Which are attracting electrons? Which are having electronegative nature. Which are having electronegative nature attract more electrons. Attract more electrons. Okay. Here, electronegativity, fluorine having highest electronegativity nature. After that, chlorine. Okay, so then answer may be chlorine. But here what is happening means chlorine having size is somewhat of less, but chlorine having more size. This atomic size is somewhat of higher. So that's why because of more size of the chlorine, it attract more electrons than the fluorine. So that's why chlorine releases more energy if you add the electron. So answer is chlorine. So greatest electron affinity is chlorine. But fluorine is the most electronegative nature. Okay. So once again, all of you listen carefully. Electron affinity is nothing but energy released if we add one electron to the neutral atom. Okay, so if any element attract more electrons, more energy will be released. But here size is also important, na? So the element must have bigger in the size and also attract more electrons. Then that is the more electron affinity. So chlorine is the most electron affinity element. Okay, that is like if you want to understand here, two movies are there. For example, we have two movies are there. One is a blockbuster hit. One movie blockbuster hit. One movie is just hit only. Okay, but here the problem is in any one town, the hit movie is released in the very big theater. Theater is very big. It having the seat capacity nearly 400 seat capacity. The blockbuster hit movie placed in a small theater, it having only 200 seats. Okay, now we have how many electrons? Let us take 450 electrons we have. 450 electrons we have. In these 450 electrons, it is attracting. It is attracting, correct? So here, this maximum capacity is just 200. So whenever this 200 is filled, okay, after that it has enough. It is completely filled. Now, remaining 250, those 250 will goes to this one, correct? Because of the more size, it can also attract the more electrons than the previous one. So this blackbuster one is like a fluorine, this hit one is like a chlorine. Because of the more size, it having more seats. Okay, so it gets more money than the blackbuster hit. That means if any small hero having got a blockbuster hit also, he get maximum 100 crores. Okay, any superstar, if any superstar got just hit or average also, he will get 500 crores or 600 crores like that. Correct? In the same way, chlorine size is very bigger than the fluorine. So it has greatest electron affinity. Okay. If they are asking lowest electron affinity, lowest electron affinity. If any element may not attract any electrons, okay, then energy may not be released. Energy may not be released. So here, if you can consider fluorine, nitrogen, chlorine, all these non-metals. Non-metals means they attract, but mercury metal may not attract. Correct? It is in the donating manner. So it lowest electron affinity is the mercury. Okay. Zero electron affinity noble gases, that is neon. So it is not at all participate in the reaction. Electronegative nature, which is a blockbuster hit, a small hero, that is fluorine. So fluorine is the most electronegative element. Okay. So there is a confusion between two only. Most electronegative, electron affinity. Electronegative fluorine. Fluorine is like a flower. Okay, it attracts bees. very effectively. But the size is small, so that's why less electron affinity than the chlorine. Okay. Okay, students, we will discuss the remaining in the next session. All of you, thank you so much for watching. Take care. Bye, guys. And if you want to download the PDF, visit www.sunilengineeringacademy.com. I have given the link in the description box also. You can download the PDF from that. Okay, thank you so much, guys.